Welcome to the explainer. So let's talk about a problem we all face. You've got this massive data set, and you know there's a story in there. Somewhere. We're going to look at how a few key SQL commands can take all that raw data and turn it into something that actually makes sense.
Okay, picture this. You're staring at a spreadsheet, right? And it has thousands, maybe millions of rows. Employee salaries, sales records, you name it. Just looking at it, it's just a wall of text. It's almost impossible to see the big picture. Well, this is exactly what SQL's aggregation toolkit was built to solve.
All right, so here's our game plan for this explainer. We're going to start with the basics of summarizing data, then we'll meet the core functions that actually do the work. After that, we'll get into grouping data to find deeper insights. And finally, we'll learn how to filter those groups to ask some really specific questions. Let's dive in.
All right, first up, summarizing your data, getting that 10,000-foot view. You might be asking, why do we even need to summarize data in the first place? Well, it's because finding the real story isn't about looking at every single tree. It's about seeing the whole forest.
Yeah. Think of it like this. Raw data is just a list. A list of every single salary in a company? That's just data. It's not really an answer. But what if you could find, say, the average salary, the total payroll, or the highest earner with just one command? Now that is an answer. That's the magic of these aggregate functions. They take that long, boring list and turn it into something meaningful.
Okay, so how do we actually do these calculations? Well, SQL gives us 5 core functions. These are basically the fundamental tools in your data analysis toolkit. You're going to use these all the time. So let's meet them. And here they are, the 5 heavy lifters of data aggregation: AVG, sum, min, max, and count. Each one of these takes a whole column of data. Doesn't matter if it's 10 rows or 10 million, and just crunches it all down into one single, powerful summary value.
Okay, let's kick things off with a classic, AVG. So let's say we're working with a university database. Instead of scrolling through every single instructor's record, maybe we just want to know the average salary. But not for everyone, just for the folks in the computer science department. And this is why it's so incredibly powerful. Look at this. With just one simple, pretty readable line of code, we're basically telling the database, hey, look at all the salaries, but just for the comp sci people, and then give me the average. Boom. You get a single, precise answer. No calculators, no spreadsheets, just instant insight.
All right, but what if you don't need a calculation like an average? What if you just need to know how many? How many instructors work here? Or in this case, how many different instructors taught a class in a specific semester? Well, that's a job for the count function.
Now the key word here, the really important part, is distinct. See, without it, we might end up counting every single class that was taught. But by adding distinct, we're telling SQL, hey, only count the unique instructor IDs. This is super important because it makes sure we don't count the same professor 2 or 3 times if they taught a bunch of courses that semester.
So, getting these single answers, one average, one count, that's incredibly useful for sure. But the real power of analysis comes from comparison. And to do that, we need to chop our data into smaller, more meaningful pieces before we summarize it.
Yeah, think about this question. A single company-wide average salary is, well, it's interesting. But what about the average for each department? Now that's a much more insightful question, right? We don't want just one number anymore. We want a whole list of averages, one for each department. To get that, we have to tell SQL to first group all the instructors by their department and then run the average calculation on each of those little groups.
And this is where the group by clause comes in. It is absolutely the key to unlocking these more detailed insights. What it does is it takes your big table and sorts all the rows into different buckets based on a column you pick, like department name. Once everything's in its own bucket, the aggregate functions get to work on each bucket one by one. And just look at what this query gives us. Instead of one single number, we get this beautiful breakdown, a table with each department name listed right next to its own specific average salary. All of a sudden, we're not just summarizing, we're comparing. We're starting to see real patterns in the data. Okay, so we've got summarizing down and we've got grouping down. But what about filtering? This is where it gets interesting. SQL gives us 2 different ways to do this, and knowing which one to use and when is absolutely crucial for asking the right questions. So think of the where clause as your pre-filter. You use it to narrow down the data you're even going to look at right from the very start. This happens before any grouping or any math. For example, you might use where to say, I only want to look at instructors who make between $90,000 and $100,000.
But that leads to a really important question. How do we filter on the result of one of our aggregate functions? For example, how do we find only the departments where the average salary is over $42,000? You can't use where for that. Why? Because when where is doing its job, that average salary for the group, well, it doesn't even exist yet. The groups haven't even been created. We need a different tool, one that works after all the grouping and calculating is done.
And that tool, as you might have guessed, is the having clause. It was literally designed to solve this exact problem, filtering your results based on the output of an aggregate function.
Okay, if you remember one thing from this section, make it this. It's like cooking. Where filters the raw ingredients before you start cooking, having filters the finished dishes after they're all cooked and ready. So, where works on individual rows before grouping, having works on entire groups after they've been summarized. And here it is, putting it all together. Look at the flow here. First, we group by the departments. Then, the average salary is calculated for each of those groups. And only then, at the very end, does the having clause jump in and kick out any groups that don't meet our condition. What we're left with is a clean list of only the high-earning departments.
So, to really nail this down, it helps to think about the logical order that SQL follows behind scenes. It's kind of funny, even though we write select at the beginning of our query, the database doesn't actually do that first. It starts with from to get the table. Then it applies the where filter on the rows. Then it does the group by. Then it applies the having filter on the groups, and only at the very end does it select and show you the final results.
All right, let's do a quick recap. The key takeaways are this. 1. Aggregate functions like AVG and count summarize your data. 2. Group by is how you create subgroups to find more detailed patterns. And 3. When it comes to filtering, just remember the order. Where filters the individual rows before you group, and having filters the final groups after all the math is done.
And there you have it. You now have the fundamental toolkit for doing some real data exploration in SQL. With the power to aggregate, group, and filter in these ways, you can go way beyond just pulling lists of data. You can start asking some truly complex, insightful questions. Really, the only limit now is your own curiosity.